Could you explain that random solar motion? I'm not clear what scale that we're dealing with here.
So the size of this box looks like on the order of tens of parsecs. So again, kind of tens of light years. And the sun is not on a perfectly circular orbit around the galactic center. Instead, it has some components out of the plane of the galaxy. So let's imagine this is the plane of the galaxy. The sun is moving out a little bit. It's moving in a little bit. And so the solar motion is not 100% circular. Instead, it's...
how big is that box compared to the
oh gosh,
radius?
I can't even show you how small it is.
But you made the comment that actually would show up on our telescopes. Maybe not ours, maybe the GBT or something. But how? I mean, is there any possible way that we can account for that or measure?
Yeah, we know exactly in 3 dimensions how the sun is moving. And so you can easily subtract that out. Yeah.
And are they using distant stars to triangulate this somehow?
There's many different methods for understanding how the sun is moving, but one of the more recent ones uses distant star formation regions to kind of pinpoint our relative motion.
So what scale is that motion compared to the Earth's orbit?
You mean the magnitude of the correction?
Kilometers per second, like what percent?
Yeah, so all of these are in the tens of kilometers per second range.
All of them?
As a maximum. It depends again on the direction. Yeah. So this one, I believe, I get these two mixed up. But these two combined is like 30 kilometers per second. And then the individual components of this motion are 10 to 20 kilometers per second.
Wow.
Yeah. And then this motion, depending on where you're looking, can be up to 200 kilometers per second. But what we want to do is, I can tell I spent too long on this slide.
But what?
What we want to do is to account for these motions and then to interpret these motions in an astrophysical sense. We'll get there, I promise.
But what's causing the random solar motion then?
It's not so much what's causing it, it's that there's nothing preventing it. Right? If you just threw a whole bunch of particles into a box, they would just kind of move around. And you could think of the stars in this box as being those particles, although they don't have exactly the same physics, right? These are a very different physical situation. They just kind of move around.
It's like a gas?
Yeah, in a gas in one sense. You could visualize it the same way. Again, the physics is very different, but you would not expect them to all be going around in lockstep in a perfectly circular orbit.
People model it using simulations and using obviously law of gravity rather than gas dynamics.
Yeah. Oh yeah, the stellar motions are relatively simple to model because you're just dealing with gravity. It's the gas motions that's complicated because you have friction and dynamic effects. Yeah.
So are there, if the galaxy is like a record, can you have waves going through it?
Mm-hmm.
And could that cause, or is there such a thing?
Yes. Yes, in fact, that's how we think the spiral arms were formed, is by what's called spiral density waves. It doesn't rotate like a record, per se, and we'll see that in our data, but the inner parts actually rotate faster than the outer parts. But there are density waves that are formed, yes. And those density waves are the location of the spiral arms. So that gives rise to the spiral structure.